Up first is Sam from the University of Arizona is going to talk about treasure maps. Some of you will have already seen it. I know Andy and others have demonstrated it. I've also seen Aaron demonstrate it. And this we see as one of the sort of one of the sorts of thing that hopscotch can be very useful in sort of supporting the implementation of it. So if you want to take it away, Sam.
Yeah, of course. So yeah, everybody, as you've probably heard over the past months or so, Andy mentioning how SCiMMA is going to be tied in and could be useful for all of these already existing utilities, like the treasure map. And so here I'm going to give you guys an overview of how it's used and give you a small demo of how the website is navigated and some API examples that already exist. Here's just an overview of our team. It's me, David Sand, my advisor, and his postdoc, Michael Lundquist, all from Arizona, and Aaron, who will be talking after me. I just want to mention that we are a worldwide organization supporting teams from 3 different countries. But yeah, just going on a little bit of the motivation behind this project. So during LIGO, during '03, LIGO detected around 6 gravitational wave events a month. So when these things go off, many groups around the world are using various telescopes to try and detect the optical counterpart, depending on what kind of instrument they use. So teams with large wide field imagers will essentially tile the larger probability localization region, whereas teams who's using smaller imagers will probably target just individual galaxies based on some sort of probability or likelihood derived in the region. And so what are some problems that people face with this? Initially, there's a lot of overlap where a lot of the same teams look at the same places as soon as the event goes off. And that can lead to problems where places get missed out on, and especially with larger localizations where areas of lower probability aren't being searched immediately. And how is this information being disseminated, whether or not it is at all? Teams who do choose to share their information usually share where they're looking through their pointings through GCNs, and they also share their candidates through GCNs. And while these GCNs are very good, they are difficult to parse and maintain since there isn't much of a standard associated with them. So our proposed solution is this gravitational wave treasure map. It's based mainly upon the API that I'll be demoing in a minute. It essentially allows users to programmatically, they submit and query their planned and completed pointings, and they can also submit and query potential counterpart candidates. We haven't really implemented the counterpart candidates yet. We're still discussing on how exactly we want to do it, whether we want to host it ourselves or host it via maybe TNS, since they host those as well. But also on top of the API, we have a web-based application where, in order to use the API, you have to register your account to get an API token. Along on the application, there is an Aladdin visualization interface, which is extremely interactive, and I'll be demoing that in just a second. And essentially everything that the API can do, we wanted people to be able to access via the web page. So there's ability to query and submit on the web page as well. And so if I click this link here, I'll get out of this and go to the splash page. Can everybody still see this?
Yeah. Well, actually, we're seeing the slide at the moment. So if you go into a web page, we haven't seen that.
All right, I'll maybe try and I'll stop and then reshare for the web page.
Okay, right. Incidentally, I'll warn you if anyone raises their hands with questions, because you probably won't see it if you're screen sharing.
Of course, I appreciate it. And so the first thing you see when you go to the website is essentially for '03, we kind of just gave an idea of what kind of instruments we're reporting. Swift and the CSS telescopes were the first 2 instruments to start demoing our API and saying that they would go along with the development process. And so they're usually pretty high up here. We were very excited to get Decam on and to start posting their pointings as well. And ZTF, those are all super awesome instruments to have on our website. And so normally during a LIGO Virgo operations, we display the most recent event, but since nothing's going on right now, we post an interesting event. And so I'm gonna go around and show you the utility of this visualization with the gravitational wave event 0425. So the first thing you see here is the interactive map with the contours, and it's one of the functionalities we wanted to have is that people can toggle on and off the different instruments and their fields of view. And we also host the gravitational wave coverage, or not gravitational wave, the GRB coverage for Swift and Fermi. And so when I toggle these on, you can get an idea of where those fields of view were at the time that the gravitational wave event occurred. And if you notice, we also have the sun and moon locations at the time of signal. And another cool interactive visualization aspect is that we have a time slider. So it kind of gives you like a history playback of how the event was followed up. And you can see how the tiling was done by the GO2 telescope here and how they were able to go all the way across the sky. And within a day, they were able to do all of that. And we also host all the...
That slider is two-handled, so you can do it on the other side as well.
Oh yeah, you can go approach it from both ends. Yeah. We also host the metadata associated with each gravitational wave event, and all this gets updated per each LIGO alert sent out for the event. And
so
one other...
Sorry, let's ask a question. You're making these associations with a given event because this is being communicated via the GCNs from the instrument?
Yes. Yeah, well, it's the VO event network. That's how we ingest all of these initial update and how whatever gets associated with the gravitational wave event. And so all of that gets ingested. We have a listener that's constantly listening on our Amazon server. And another cool aspect...
But the individual pointings are sent in via the API.
Yeah.
Okay, cool.
And so to move on with the visualization aspect of the web page, we also have a coverage calculator, where you can select an instrument or say a depth, and you can get an idea of how the event was followed up, covering the probability region. It takes a couple seconds to compute the coverage. And so you can say that within a day, the GO2 instrument was able to cover 25% of the localization region. And it just kind of gives you an idea of how well the event was followed up. And so next I want to go over, I'm kind of running out of time here. I want to go over the API and how it works. So on the website, everything here is pretty well documented. Once you create a user account, you'll be able to use all of the API endpoints. And so for posting, getting, and updating the whatever pointings you want to submit can all be done via the API. And all of the examples that we have here are done in Python, but any sort of programming language that implements HTTP requests can be used to post and get and query from the API itself. We can go down, you can query for the instruments. One thing we wanted to do is to give our users essentially validation for their efforts. So we implemented DOI requests, which is a digital object identifier. And when you post your pointings, you can essentially get a citable URL that you can use to put in papers or essentially cite however you got your data from the treasure map. And this is all of these DOIs are linked essentially to the individual pointings or to a batch of pointings. And we also want to give the users the ability to tie published papers already. So essentially, say if they published their pointings post facto and they already have a paper published, they can use the DOI from that paper and associate that to that pointings, which it isn't fully implemented yet, but it's in development. And later, Aaron will talk about uploading convolved galaxy information. Along with this documentation page, we also have a Jupyter Notebook tutorial where everything here is everything here works and runs perfectly. You can query for instruments. It also gives you essentially the same examples that were on the previous page, but in a Jupyter Notebook environment. And we also go over another API feature where you can get instrument information, so you can get essentially the footprints of another instrument and give you the ability to essentially recreate a pointing or how an instrument team followed up a gravitational wave event. But that's pretty much it where the API stands right now. So I'll go back to the slides.
Oh, wait, before you go back to that,
yeah.
Could you demonstrate a little bit of, can you demonstrate a little bit about zooming in on the Aladdin interface and just changing the background layer and show people how you do that?
Of course. Yeah, so with each of the events, the Aladdin interface gives you the ability to, it's a little bit more interactive than I showed, but you can zoom in on a certain region, and I think the term is called slippy maps, where they will update their resolution in real time as you zoom in, so you can kind of get an idea of what exactly a pointing was looking at, whether it was an individual galaxy or just where they were at that time. And on here, you can change the base image, layer to be swift bat flux, or you can get an near infrared field of view or background, or you can go to the pan stars. They host pretty much all of the available surveys. Is there anything else you want me to show, Andy, that I forgot to go over?
I think people get the idea from that. Yeah. Or you can just zoom in and out, and then if you turn off all of the fields, you can just see where the gravitational wave contours are there.
Yeah, you can do that too. And for each of these events, the gravitational wave contours get updated well for each of the updates. So the main takeaway from this is let me go back to full screen. So currently at the end of 03, we had around 19,000 completed pointings reported from each of these, from 20 different instruments. But the main takeaway from all of this is that most of these pointings were posted after the event transpired. And what we really want to do is encourage our users to use this utility in real time and have some sort of observation plan where they can constantly pulling and updating from the treasure map via the API. And so they can update their observation strategy and minimize the amount of time it takes to find a gravitational wave counterpart. But next, Aaron will go over the future of the gravitational wave treasure map. And after that, I guess we can start taking a little bit more questions.
Okay, I just have one question before we move on. And it's really cool. This sort of future mode where you can be used for coordination by algorithm, I guess.
Yeah.
At that point, is essentially what you're offering is a almost like a real-time database of what's been done for this particular event.
Mm-hmm.
And then the visualization will be something for people to look at, but it's not necessarily going to be what the algorithm is going to be using, or I assume it's not going to be.
Yeah, the visualization was kind of like a cool aspect initially that we wanted to essentially build a user base, because that's something people want to see like in real time, or how things are getting updated, or how an instrument footprint is being followed up. But yeah, the main strength of this will be a real-time database for these events.
Yeah, I also wanted to point out that, you mentioned that a lot of people are putting them in after the fact. That one reason for that is that, we rolled this out during 03, and then grew awareness in the community sort of as we were going along. So a lot of people didn't know about it during real time, and also there wasn't as big a huge community event in '03 as there was for GW17, 0817. So there wasn't one thing where every single person followed really. But and there are multiple ways people use this. So some of it is for coordinating to see what everybody else in the world is doing, and but also even if you're not a person who cooperates, there's a lot of utility in just seeing like, okay, how much did my own planning your own group's observations, or seeing how much of the parameter space was covered, calculating the coverage probability, getting a reference for this to use in your papers and so on. So there's a lot of different ways people use it.
Yeah.
Okay.
Any other questions?
Yeah, and we will have time, as you say, for questions after Erin has sort of closed the loop by showing the planned future.
Mm-hmm.
So, are you able to share your screen, Erin?
Yeah, let me do that. Can you see the slides?
Yeah, you're very quiet though.
Can you see the slides and can you hear me better?
Yes, I can hear you now and I can see the slides.
Great. Yeah, thank you, Sam, for the great introduction for the treasure map. I'm going to talk now about some planned features. Some of these were even requested directly by users in the community, and I would say before I get started that if at any point there's something that I'm saying that you think is cool but think could be done better, or you have a totally different idea, we are very open. Treasure map is supposed to be a community resource. It's all being developed publicly on GitHub, and we are very open to taking both commits, that would be great, or even feature requests if you don't want to get your hands dirty, and we'll put it on our list. Okay, let's get started. The first thing that I really care about making treasure map is a robust wavelength and messenger agnostic system. We don't want to privilege any particular wavelength or messenger, and unfortunately we currently do. So here I'm going to talk about a current limitation of the treasure map, and that's, Sam talked about how the API allows instruments to post their pointings, and associated with a pointing is a RA, a deck, a position angle, a depth of the coverage, and a band, and some other things. Unfortunately, right now the bands are strictly defined as one of these UBV, RI, JHK, blah, blah, blah. And this is problematic because in the last few months we've had radio observers like ASCAP and extremely high energy imaging atmospheric Cherenkov telescopes like HESS come in and start reporting for the treasure map. And we realized that we had built this API in a way, and the backend in a way that privileged filtered instruments. So this is obviously a bad thing. So how are we going to fix this? We're going to connect the treasure map to the SVO filter profile service, which basically is a database that hosts the actual wavelength coverage and filter profile for all the filters. But then actually in the back end of the treasure map, stop caring about filters. Filters will just be aliases pointing to a frequency dictionary. And then alter the API to allow non-filtered instruments like X-ray telescopes, gamma ray telescopes, and radio observatories to report their coverage frequency bands explicitly in the unit of their choice. So instead of having to predefine a filter object that they report their depth in, they can say, we reached 5 times 10 to the minus 12 ergs per centimeter per second squared from 0.3 to 10 keV, for example, something that Swift X-ray telescope might do. And why I think this is important, even though it's kind of detailed, is that in order to really serve the community, we have to serve the entire community. And I feel like a lot of tools and facilities to date have been built around optical observers, and that's not a good thing. And in addition, storing everything in the back end in frequency space instead of referring to these an actual physical unit as opposed to referring to these filters will allow more detailed and arbitrarily complex calculations, like the one that Sam demonstrated with the coverage by go-to and whatever the go-to band was down to 18th magnitude. We can basically adapt the API to allow you to integrate the coverage on any way, on the wavelength axis from any range that you want. And that allows theorists to start getting involved and saying, okay, my model for a kilonova predicts this luminosity in this band. What are the upper limits for that? And they can plug it into the calculator and just will return, in whatever parameters they want. Now, there's still an open question. How do we extend these to, how do we really be agnostic about messenger? Because everything I just talked about is about storing things in depth coverages in the back end with electromagnetic frequencies. And I'm yet unsure how we're going to do this for instance, IceCube or Antares reporting neutrino flux upper limits. So I'd be happy to take suggestions on how to do that. But I wanted to lead with that just because I think it's important that we be that when we build these tools, we try to serve as much of the community as possible. And this is one thing that I identified with our current system that does not do that well. Okay, let's move on to something more interesting. Maybe. So one future feature that we're working on now that we have a prototype running is serving galaxy ranking information. So as you may very well know, many people who do gravitational wave follow-up do not have extremely wide field imagers, and so they rank the galaxies in the gravitational wave localization region and assign them scores and then work down the list observing each of those galaxies. There are many different techniques and methodologies that exist to do these rankings. For GW170817, and the host galaxy of the event NGC 4993 pretty much showed up in the top 15 for every different ranking methodology that existed at that point. But now there's a lot of different people working on these things, and sometimes they can be hard to access, or they require you to set up in advance and download the code and do all these things. And so we have this idea that TreasureMap will basically serve as a clearinghouse, and we will serve and or calculate ranked galaxy lists from any group or method that wants to participate. This example here is using the ranking method that Swift uses, which was developed by Phil Evans. Let's just pull it up real quickly as an example, just so you can see what's going on, or what would happen on the visualization side. The idea would be to store all of these ranked galaxy lists in the back end and then allow people to query them, or query things as a function of, so let's see, there's all these galaxies, and the visualization engine allows you to click on one and it gives you the score and then some contextual information that might be useful. And that's interesting from a visualization point of view. But again, the real power of TreasureMap is the API and the back end. And really what we want to do is put all of this information in our back end so that's easily queryable by anybody who wants to either compare the different rankings and scores for, the same galaxies in the localization region based off of different methodologies, and really provide a one-stop shop for how this is going to be done, because there's really a real diversity of ways that people do rankings. And you have to sort of go to a lot of places right now to find them and download them. So that's one planned feature that we think will be useful for the community. And in addition, and in particular, it requires some standardization, either of how the groups that produce these rankings will send them to TreasureMap, or TreasureMap could even, host the code locally on the TreasureMap server and calculate the ranked list using their method, and then provide a citation to that method. One really important thing, obviously, is ingesting counterpart candidate info and coordinating characterization studies. Sam mentioned this briefly, but as everyone knows, during '03, there were many candidates that were discovered. Most of them turned out to be supernovae or flaring AGN. But confirming a candidate as the counterpart or disconfirming it requires sensitive spectroscopy and multi-wavelength follow-up, and no single group has access to all the required facilities to do this alone. In addition, there's too many candidates to waste redundant spectra or space telescope follow-up resources on the same one. So you really need to coordinate. Even if you don't want to coordinate the wide field search, we really need to coordinate the characterization. TreasureMap already has the latent capabilities to do this. All of the capabilities that allow you to post planned and completed pointings and observations for the wide field tiling search can be easily adaptable to coordinate counterpart candidate characterization. In particular, when there is a strong kilonova candidate, we really require well-cadenced and frequent spectroscopy at early times, and this requires coordination of the powerful telescopes with good spectrographs across the world as the source rises and sets around the world. And so in order to do this, obviously people have to start doing it, but we also have to get these counterpart candidates into TreasureMap. And this is currently an issue because most counterpart candidates, unless they're discovered by one of the wide field timing machines that goes into a broker are just reported in free-form GCN circulars. So we require a way to get these candidates objects into the treasure map. The prototype on this will be the Swift X-ray telescope candidates, because these are reported via GCN notice in a machine-readable way. But the plan is also to then ingest all of the TNS candidates in a certain time range in the region. And from the perspective, yeah, go ahead.
Sorry, I just noticed a question from David Kaplan. I think I missed it from a little bit earlier, but David, do you want to ask your question, or shall I? I can read it out.
Sure. So, Aaron, we were talking about the wavelength agnosticity, and I appreciate that we had some discussions about this several months ago. There's also the question of your field of views being defined as, sharp geometric regions with hard cutoffs, whereas, especially for many radio and high energy instruments, it's more of, a graduated sensitivity that will be energy or wavelength dependent.
Yes, thank you so much. This is an extremely useful point, David. And I should say that the conversations with you and Dougal and Tara several months ago really helped, figure out how we were going to serve the radio community. Yeah, but this is a good point. What David's pointing out is that the way that we define footprints currently in the back end are strictly defined polygons of, projected footprints onto the sky. But for instance, it might be a better description to describe the full width half max sensitivity region for a radio telescope or a gamma ray telescope. We are open to guidance from the community on how they want to deal with this. I think at the end of the day, what we're going to have to do is just adopt a standard like the full width half max at the median, at the average wavelength in the observing band, and stick with that. We certainly could have a more gradually defined, PSF stored in a HealPix format, but then that becomes very computationally expensive. So this is an example of how difficult it is to really support all the different kinds of instruments that do this follow-up in an agnostic way that really serves everyone, and it's an unsolved problem.
We do have the ability to deal with HealPix maps for the, that's how we have the localization stored. And we have been talking about, combining gamma ray sensitivity or localizations with GW localizations. And we've talked to IceCube people about, how they want to store their information as well. So.
Right, but Andy, that's referring to detections, and what David's talking about here is coverage, and it really, I'm pretty sure that storing pointing coverage in the HealPix is not really going to be the right way to do it. But let me finish my talk, and then we can get back to that if people want to talk, because I'd love to hear people's suggestions on good ways to do that. Okay. So yeah, so I was talking about counterpart candidates. So this crucially requires that people report their candidates in a machine-readable way, and I think it's clearly very well motivated. We don't have enough resources to not coordinate spectroscopic and other multi-wavelength characterization of all the candidates. Okay, another future capability, or one that's again already latent, and this was brought up in response already to Sam's talk, which is that Treasure Map can, and in fact was originally designed to serve to coordinate the wide field tiling searches. During 03, Swift, Las Cumbres Observatory, and SAGUARO actually posted their observing plans before they did them, and then updated them with their completed ones. So if people had been watching and had wanted to, they could have either coordinated or made different observing decisions based off of that information. There's a little cartoon on the right where we're sort of demonstrating that at early times, right, everyone is pointing in the same place, and we might miss the kilonova out at the 50th percent contour, but in reality, the latent capability exists to cover everything very quickly if only people coordinate it. Now, of course, everyone's always going to go for the highest probability regions, especially if they have a powerful facility, but there are some facilities that certainly just are not as powerful and cannot compete with the likes of ZTF, and can actually leverage and increase their chance of a discovery by tiling around that. And so the idea is that people, in 04, hopefully more instruments will report their plans in real time. And then the idea was on the back end, TreasureMap would identify the highest probability areas or galaxies that are being missed and can then serve those back to the community either robotically or however, as suggestions of, oh, if you have a telescope, it might be good to point here because no one's looking at here, as a function of depth, as a function of wavelength, whatever you want. So this is one of my favorite use cases for TreasureMap that I'm very excited about, and has a lot of overlap with work that's been done, for instance, by the Grandma team and by Michael Coughlin with his GWEMOP for coordinating heterogeneous telescope networks. And it could definitely plug into that. TreasureMap is just the back end that stores all this information. So that was most of the really big things that I think will serve the community. Here's a list of other things that we're working on for coming planned features. We had a request from people on the DECamp team to allow you to associate your paper's digital object identifier with the custom pointings collection. Currently, TreasureMap will assign a custom pointings collection a DOI, but they wanted to take their DECamp paper and assign it to that. So we're going to implement that sort of backwards compatibility. We have a prototype working to auto-ingest the TESS and other wide field stare coverage in the same way that we automatically and within seconds can calculate the coverage of the gamma ray burst facilities to a gravitational wave event. We are trying to figure out ways to serve candidates that are not well localized, like neutrinos and gamma ray bursts. We did this for one event from Fermi GBM in February of 2020. But for neutrinos, this requires IceCube and the other neutrino facilities to report their localization regions in HealPix or some other standardized format. Some other things that we want to support are different API formats that have been adopted by other parts of the community, like the IVOA OBSLOC TAP, supporting plugin to the TOM toolkit. And crucially, this previous idea about serving suggestions to the community requires having a knowledge of which observatories are currently online. As some of you might have known, when COVID started, TreasureMap served as a sort of a very rapid host for the human input statuses of observatories. And we're thinking about how to turn this into an API that can allow robots or scripts or algorithms to query the observatory status or availability. But this is a very hard thing to do, obviously. So yeah, that's all I have to talk about today. Sorry, I went a little over time, and I'm happy to take questions.
While we get set up for questions, maybe you could just show that observatory status page on the TreasureMap.
Yeah, sure. Let's go there. I haven't actually been there in a while.
So if people could raise hand for questions, I think we probably would want to limit it to 4 minutes so that we give Dave 20 minutes to talk about SAGUARO. But
yeah, so here's what I was just talking about and what Andy said. Hosting. There's a lot more green on this page than there was a few months ago, which I'm very happy to see. And the idea would be to turn this and build an API whereby we could either query statuses and pull them from observatory websites or have observatories ping us with updated information. And of course, all of this stuff that I'm talking about interaction between algorithms and the TreasureMap and back and forth could be very well facilitated by a client like Hopscotch.
Yeah, that's a question. Are you thinking of specifying the API for that sort of observatory interface, or would you somehow consume all of whatever they offer?
So this is a very good question. I think there are always going to be some observatories that will say, well, if you go here and, ingest this in the format that we already have, you can find out. And I think sometimes we might be inclined to do that, but there's just going to be too much heterogeneity to have us, constantly pulling that. So it would certainly be ideal to define or come up with a standard that people agree upon for observatory statuses. Obviously, there's a long history of people trying to build standards. TreasureMap sort of bypassed all of that by just deciding on our own API standard for pointings and just convincing people to use it. We are more than happy to, consult with the community on what works for everyone.
So we did decide that was something good for the TOM toolkit that's being developed at LCO. And we have had discussions with ourselves and few other observatories about how that would work, and it gets to be quite complicated because each observatory is so different. So I think what we're going to do initially is try to support multiple methods of that communication. Right now, that's a spreadsheet that you can just go and edit on TreasureMap. So that might be a place to start, but then we'll work with other observatories to figure out the best way to do that.
Okay, cool. That makes sense to me. I see M. Coughlin has a hand raised.
Hey, Aaron, really nice talk. So I was curious about your sort of the coordination plan stuff. So what level of, let's say, information were you imagining that the potential user would provide to then get out, I would assume, a like revised SCiMMA or a new schedule or what have you? What kind of, let's say, inputs were you expecting people would put in to sort of?
Thanks.
Yeah.
This is a great question, Michael. I mean, you're very familiar with the different ways to do this. I think the first step would literally just to be serving, just calculating what is not being covered and having a list that people can ping with their robot or their API saying what area is not being covered right now. We could certainly support in the future doing something more complicated whereby, you provide your telescope's location, field of view, observing bands, and reasonable integration depths, and then it would calculate what the in real time recalculate what the optimal distribution of targets would be, very similar to how you currently distribute targets to grandma. And to be clear, TreasureMap is not trying to replicate or sort of, what's the word? Double, rebuild what you've built. We are serving as the back end here, and we are happy to use whatever methods the community wants and whatever features the community wants. And if you want to hook GWEM opt up to our back end and recalculate in real time based off of what people are reporting, we would be happy to support that.
Yeah.
Okay, I just have one quick question. So you allow some sort of post facto additions, which I think makes a lot of sense. Do you record that as a something that was added after the fact, or would it look as if it had been? I mean, obviously in the case of a DOA of a subsequent publication, it would be obvious. But if someone was adding extra data to something, would it be obvious that was that information was added after the fact?
So all of the current information that's stored in the TreasureMap from users or from other things is timestamped with the time of the observation, right? So for instance, a few weeks ago, the DECCAM team went in and uploaded about 600 of their pointings, and every pointing is time tagged with when they took that pointing. In the back end, we can track, on the admin side, we can track when that was uploaded, but that I don't think that information. Well, if you tell me that information when someone uploaded something, not just, as opposed to when the observation was taken, if you tell me that's something that would be useful for the community, we can certainly think about making that open and queryable as well.
Yeah, we just wondered about it in the Hopscotch team, in case there are claims of precedence and things like that. Obviously, when people say they observe something is important, but all we can control is when it arrived at us. We can't sort of verify.
That's right. Yeah, and we decided when we were conceiving of TreasureMap that we are not trying to be, the gods of the universe, and, we trust our users. And when users say they pointed somewhere at a certain time, in most cases, that's almost impossible to verify until, the data is published. So we just trust the users, and we have a no a-hole clause when you register for our website.
Andy's mentioned that before. Okay, so actually, is Dave Sand actually on?
I am. I'm sorry. My daughter's name comes up for me, and I couldn't change it. But yes, I'm here.
Delilah Sand. Okay.
Yes. Let me. I could share my screen real quick.
Yeah.
If you're ready.
Thanks very much for that, Aaron and Sam. That was really helpful, actually. And TreasureMap continues to be awesome.
Okay, so I was asked to talk about SAGUARO for a few minutes. We have a really interesting acronym, tortured maybe, and a logo. There you go. And there's the core team down below. I hope everyone can hear me. And most of the hard work, of course, was done by the postdocs, Carrie Patterson and Michael Lundquist. You can see our initial results in this AppJ letter down there. Okay, so SAGUARO is both a search and discovery gravitational wave follow-up program and a follow-up program for interesting candidates, although we mostly just exercise the discovery aspect during O3. Our discovery is based off the Catalina Sky Survey. So the Catalina Sky Survey is this near-Earth asteroid program. They actually use several telescopes, including this 1.5 meter telescope up on Mount Lemmon. It's a site run by University of Arizona. They have a wide field of view imager on that, and they map about 1,000 square degrees every night during their normal operations. And so they revisit fields 4 times within a half hour with this 5 square degree imager to search for near Earth objects. And in fact, they're one of the most prolific groups at doing this. And so we kind of piggyback off them. And when an alert comes in, we let them know. We have electronic communication with them, and we trigger somewhere between 60 and 180 square degrees within the localization. So on the bottom left that's sort of the standard tiling that the Catalina Sky Survey employs. And so we have deep template images of all of those fields that you can see there. They sort of avoid the plane of the Milky Way. And so we triggered on 8 gravitational wave events in O3. We issued about 8 GCNs. We post all of our pointings to the gravitational wave treasure map. Now, one thing that we're still putting together is, the CSS does observe 1,000 square degrees per night, night after night. And so we actually have a significant amount of serendipitous data for many other gravitational wave events. So we have analysis of 9 other GW events ongoing. And we hope to have this more online in O4 and beyond. But this just gives you some idea. We're a real-time transient search. We found some supernova. That's not really our area, what we're focused on here. We're really focused on following up gravitational wave events. And in principle, once us or someone else in the community follows up or finds an interesting candidate, we at the University of Arizona have significant follow-up resources. So we have the 6.5 meter MMT telescope. That's actually an old picture of it. It's no longer multiple mirrors. The 90-inch Fock telescope, the LBT, you can see on the bottom right there, it's twin 8.4 meter telescopes. My co-PI, Wenfei Fong, has access to Keck. And a whole slew of other small telescopes, 1 to 2 meter telescopes that we could use in a rapid TOO fashion to follow up interesting candidates. We also, we try to be as inclusive as possible. We directly collaborate with many other groups. We've gotten together, we've written proposals with them, etc. During O3. I look forward to these kind of deep collaborations once we have real counterparts in O4 and beyond, I hope. So we haven't quite executed on all these collaborations. And I think that's an area of growth for future runs. So this just gives you some idea of both our discovery and follow-up capabilities. So here's our CSS search. So we just put, whoops, I screwed that up, hold on. I just put the GW170817 light curve here at 40 megaparsecs, shifted it to 100, 200, etc. And you can see our CSS search. We go to about 21.5 magnitudes. We are sensitive in the first day or so to kilonova, like GW170817, out to about 200 megaparsecs. Of course, we realize now in O3 that maybe that's not good enough. And then our follow-up facilities, this is for imaging with our 2, 6, and 10 meter telescopes. You could imagine with this sort of mini network of telescopes at Arizona getting decent light curves out to 200 megaparsecs, out to 10 days or so. If you have a GW170817 like event, here's sort of the near infrared coverage on the right as well with our bigger telescope access. Okay. Here's just some examples of our follow-up and our tiling that we did during '03. This is all going to come out in Patterson et al. This is a postdoc. Kerry Patterson is a postdoc at Northwestern University. This is the burst event, which I really hope is real. Please don't tell me otherwise. Here is our follow-up over several days. This actually includes our serendipitous pointings of GW 190425. Okay. And here are a couple of nice summary plots of what we were able to do in '03. So, you know, don't take this as gospel, but this is the rough depth of ZTF growth. Go to Atlas up here, Pan stars down there. And each of these points represents one 5 square degree pointing that SAGUARO implemented through our CSS search during '03. So it gives you some idea of our depth for a given pointing. And over on the right, we took I believe we took the median distance for each event, okay? Overplotted some kilonova and other possible counterpart models. And you could see the depth that we're getting to each of these downward pointing arrows for each of our events, for each of our individual pointings. What's the takeaway here? Well, for the most part, so this solid line is a GW 1708-17 light curve. For the most part, we were not going deep enough, and I think that's true of most of the groups that were searching for counterparts during '03. So you can see there's just a couple of events where we were really sensitive to sort of most normal counterparts. Okay, so what are we going to do going forward? I'll just tell you real quick. I'm really nervous about going deep enough, and so we are upgrading our prime focus imager on our 90-inch telescope here in Arizona. We've ordered new CCDs. We're replacing a Dewar window, guide camera, focus, et cetera, et cetera. I'm happy to talk about that. And our intention is to operate this 90 prime 1 square degree imager in a Q mode during not just '04, but for time domain programs in general, starting in early 2022 or so. And so what's it going to look like? This is probably a little complicated. There's a gravitational or neutrino alert. We'll do our Catalina Sky Survey wide field search, especially for nearby objects. We'll also do perhaps a smaller area but deeper search with this new upgraded 90 prime wide field instrument. Okay, we intend to update the community continuously via the treasure map and the transient name server for any candidates we may have, or whatever the successor to these things are. Okay, and if we find something interesting, we have access to a range of facilities to follow up these candidates. Of course, there's a lot of software work that goes into this. The arrows don't do it justice. And you could also imagine localization fill-in with the 90 prime wide field search, kind of what Aaron and Sam have been talking about, the neglected regions of localization. And then feed that directly back to the community as well with updates to the treasure map, transient name server, or whatever mechanism there is for disseminating candidates going forward. And so here's a list that I think we kind of already seen at some level, most of these things in the 2 previous talks, but what would be useful to us? A GCN-like system that is machine readable. I think that's one of the biggest things. If we could parse candidates in real time without sort of a person filling in a form or something, that would be great. TNS is great for reporting optical transients. It would be great if something like it were to expand to the X-ray radio regimes as well. And I know there's some work in that direction. Some kind of clearinghouse for candidates within localization regions. Maybe this is where the transient brokers come in. I'm not aware of something like this at the moment. So there needs to be some development there. And this has been touched on as well, a communication system for planned follow-up. I would really like to know if someone has planned spectroscopic follow-up. I don't want to waste my 8-meter time if someone at the GTC or whatever has already taken a spectrum of something. And I know this actually happened a lot during '03, is you get half a dozen 8-meter spectra of the same boring type 2 supernova. Okay. this has also been mentioned. It would be nice if there was a standardized HealPix format or whatever it may be for neutrino alerts as well, especially when they're coincident with a GW event. We've heard about telescope plus instrument availability and maybe accessible via some API. I'm also quite interested in knowing the footprint history of some of the big surveys like ZTF and Atlas. If Atlas looked at a field the night before and now there's a new transient there within the GW localization, that's a more interesting transient to me than one that is pretty stale. And so it would be nice to know where the big surveys have looked preceding a given event. And I could also imagine a data analysis service, where you could test kilonova light curve models on your early light curve data, photometric redshifts, et cetera. Right now, I think most observing groups are doing this on their own. And, that's fine. We could probably do that. We mostly do that on our own. But I think for some of the smaller groups, it would be nice to have some kind of service there. That's really all I had to say.
Thanks for that. Does anyone else have any questions? I have a question I wanted to ask, but I wondered if anyone else would like to raise their hand. Well, while other people are thinking about this, well, in that last slide we showed what could SCiMMA do for you. That brought up a couple of things I was thinking about. How do you actually make your decision as to which things to pursue, given that there's only finite telescope time, and you could have more than one candidate to look at? What actually allows you to make that decision?
So do you mean for an initial search, or do you mean for the actual follow-up of a candidate?
So for follow-up.
Yeah, so right now, we look for something with the right redshift or photometric redshift to follow up. Frankly, our group, because, for me, it's much harder. There's some politics involved for, throwing someone off an 8-meter or 6-meter telescope at our institution and getting a spectrum. And so we were much more cautious than someone with, say, Gemini time, public Gemini time. And so we really wanted something that was a real juicy target at the right redshift, at the right luminosity to be GW 1708-17 like. And for these localizations that were thousands of square degrees, we basically opted out. We thought that it was a waste of telescope time to actually follow these up in any serious way, to be perfectly frank with you. Right, I know not everyone agrees with that.
That makes sense. So I guess when you're saying about things like, did someone else look there yesterday, there's extra information that you would like to have to decide to make that decision to kick someone off a telescope that you don't currently have access to.
Yeah, that's right. Here at Arizona, we're like a nice family. We think we're a nice family, right? And so if I started kicking postdocs and grad students off the telescope, I would get in trouble pretty quick. And so we want really all the information we could get about a given candidate before we trigger on it. I wish we were able to be a little more gung-ho about things, but the fact is we cannot.
And Adam, to add a little bit more information, a lot of times this happens with just like phone calls behind the scene, like, or like a bunch of us are in Slack channels that we've just ad hoc sprung up to coordinate people that are sometimes working together, but sometimes not working together. And we just discuss, okay, if you're going to trigger Keck, I'll trigger Gemini, or I'll do these subset of targets. I started up a spreadsheet and sent around a link to a bunch of people in the community so we can try to coordinate. So the problem really is that there aren't these tools that everybody would like to be available. So we're just doing, even Twitter and stuff. I mean, you're trying to look at any way of communicating this information in real time.
Yeah, that's right.
Okay, and that's good because tomorrow we're having a conversation about what the SCiMMA database of things which pass through hopscotch will be, and in some sense that is and certainly can be an aggregation service, because we'll be seeing things from more than one server. You won't have to go to GraceDB and then ZTF or LSST's or VRO's archive. If everything that goes through our service should be in our service, so that sort of raises the stakes for our aggregation functionality, but it means it could be useful to people like you, I think. You could have that.
Absolutely. Yeah, absolutely.
Cool, that's good to know. We're nearly at the hour. I wondered if anyone had any more questions for Dave or any of the other speakers. And I would say this is really valuable. I'm involved in the SCiMMA development team, and this is really valuable to us because the last thing we want to do are create solutions that have no problems. So for us to hear from the astronomers as to what they want, and also you know, key sort of clients like TreasureMap as to what they're doing, this avoids a lot of wasted effort, both in overlap and also in generating things which aren't fit for purpose. I see Patrick has his hand up. You're muted, Patrick.
Yep, I was just trying to get to the right place. I'm on my phone. Sorry about that. By the way, thank you very much for the talks. I thought they were great. I like the highlights of various opportunities for interaction and also needs for more generic solutions. Can I put out there, in addition to what you said, Adam, the comment that I think, you know, the group that has been SCiMMA and then the community that we want to have be SCiMMA, there are representatives from both, from the ones that are already deeply involved and then others who are are operating within the community environment. I think we want to start to find ways to actually make the collaborations more sort of real, I think, at this stage. And to me, I just want to highlight that these two presentations, plus the presentations we've seen in the previous couple of open telecons, really, to my mind, represent good opportunities to begin doing that. So if people who are not sort of, say, you know, participating in what has been the SCiMMA project part have suggestions on how we can begin to sort of get everyone moving around in the same circles and working together a bit more, please pop them either by email, over the Google group, whatever, to me, to Adam, to Andy, you know, it doesn't matter who, just feed them back to us. I think over the next few weeks, we really want to begin ramping up that broader sort of effort of working together and to kind of broaden out into a more of a community as we go. So I just wanted to highlight that because it just looks to me like we've got these things that could benefit from some unified planning in the coming months in preparation for, you know, the next round of big multi-messenger observations. Or
yeah, I agree with that too, Patrick. And I did want to point out one more thing that so TreasureMap has been just a community effort because we thought it needed to be done, but there was no funding for it. We did apply for NSF funding and got turned down. So this has been a huge amount of work has been done by Aaron and Sam, who are both grad students, just doing it, you know, while they're doing their other science. And so that's been a great effort, but it's hard to sustain in the long term. So without funding, so you know, we can do what we can in SCiMMA where we are funded, but also just there is a need for the community to fund these kinds of efforts as well, and also just to work together as a group where we can, where we think it's important, like has been done.
Super, yeah, and then maybe we can, you know, use that to make the case for funding an ecosystem, which is something that I know at the NSF they're very much aware of in terms of cyber infrastructure and data science, and so we should let's again, I charge us all to find a way to really get everyone engaged and begin to make this case and begin to, you know, get effort where we need it.
And that's a good note on which to finish, I think. Absolutely, the next month, 2 and 3, I think are going to be really important for sort of bringing the community together, and that goes both ways. We would really like to hear what people want so that we can work out how to deliver it. So thanks very much, particularly to Sam, Aaron, and Dave for giving those very informative talks, and to all the other attendees. And we will be holding another one of these in the first Tuesday of September. And you'll be able to find this one on the SCiMMA YouTube channel, to which you should all subscribe, probably by tomorrow, I think. Thanks, everyone.
Bye-bye. Thanks, Adam.